Migration bundles are an excellent tool for applying migrations in integration tests and shared environments. And it takes a well-thought-out plan to deliver that tool to the right place. So let's consider our constraints. Integration tests verify that the components of an application work well together. An important pair of application components to integrate are the domain services and the persistence layer. In Entity Framework, the persistence layer is implemented within the query provider, and it relies upon the SQL configuration and migrations that we've added to our code. And so, an important aspect of integration testing is to make sure that we've configured the persistence layer correctly. The only way to truly make sure that we've configured it correctly is to connect the application to a real database. But we want this database to be isolated. It should exist only to run integration tests. It should not interfere with the testing being performed in any shared environment. And it should be able to run within an automated continuous integration environment. These constraints suggest Docker as a solution. Docker Compose is a tool for creating small clusters of related containers that can communicate with one another. One of those containers can be running SQL Server, while the other one is running the integration tests and the domain services. If we deploy the migration bundles to the integration test container, then we can be sure that the database is up to date before the tests begin. Now let's consider deploying to shared environments. Migrations require elevated privileges, as they will be running DDL and DCL commands, and so they will need their own connection string. But that's not enough. The migration bundle also needs to be able to establish a network connection to the database. So it matters not just who runs the migration bundle, but where. If your target database is in an Azure SQL instance, then you'll need to deal with the network security. An Azure SQL instance has a set of firewall rules that restrict network access. Now, it's common to add a firewall rule allowing other Azure resources to access the database, or at least opening it only to certain virtual networks. But it is not recommended to open the firewall to external IP addresses, such as release agents. If you were to run the migration bundle on the release agent, then you would need to be able to connect to the database. And that means that you would need to add a rule to pierce the firewall for that database connection. A better solution is to deploy the migration bundle into the target environment. That way, it could run within the already configured address space, such as a virtual network. Again, this solution suggests Docker, and here's what I recommend. Build the migration bundle into a Docker image and upload it to a protected registry. Tag the image with the build version so that the correct version can be deployed to a target environment. And then configure the release agent to deploy the desired version by its tag as a Docker container. The container runs within the target address space and pulls the migration bundle from the registry by tag. After the migration bundle runs, the release agent deletes the container. So the solution for both integration tests and shared environments depend upon Docker. Let's do a quick review in order to set us up for building these solutions. If you're already familiar with Docker, then you can skip this introduction. We'll just be going over a few basic commands. Or, if you want a deeper understanding of Docker, then there's no better place to start than Nigel Poulton's Getting Started with Docker. But just to follow along with the demos, here's what you'll need to know. We have two important concepts to keep separate in Docker. There are images, and then there are containers. You can think of an image as a snapshot of a hard drive, whereas a container is a full running machine. That's not exactly right, but it gets you into the right mindset. You can get Docker images from a number of places. Docker Hub is a public registry of images, kind of like how NuGet and NPM are public repositories of packages. On Docker Hub, you can find entire operating systems like Ubuntu Linux, or databases like PostgreSQL, or infrastructure components like RabbitMQ. Microsoft runs a public repository called the Microsoft Container Registry, or mcr.microsoft.com. They make this registry searchable through Docker Hub. There, you can find images for the .NET SDK or the .NET Runtime pre-installed on a number of different operating systems. You can also find SQL Server. That's right. Imagine a hard drive with SQL Server installed on Linux, just waiting for you to plug it in and boot it up. Okay, it's not exactly like that, but you get the idea. You can also host a private registry. This is useful not only for hosting approved images, but also for publishing your own private builds. All major cloud providers give you an easy way to create a private registry. In Azure, this is called Azure Container Registry, even though these are images and not containers. Whatever. And finally, you can have a local registry right on your own machine. This is where you'll temporarily store images before pushing them up to a private or public registry. And you can build those images by writing a Docker file. A Docker file is a set of commands for building an image. It starts with a from command, which specifies the base image. It's as if Docker boots up a machine starting at the base image and then starts applying the commands from there. Here are some of those other commands that you'll see. Workdir sets the current working directory of the image. Copy copies a file from your machine into the image. Run executes a shell command in the image's operating system. And entry point tells it where to start when a container based on this image is finally run. We'll also see a multi-stage Docker file. It has two base images and two sets of commands. The first set of commands are typically a build script and produce some output files. And then the second set of commands can copy those output files into the final image. And so, to build an image from a Docker file, you have to run docker build. Use -f to specify a Docker file, and give it a folder on your machine from which it will copy those files. You can also use -t to give it a name. The name of the Docker image is made up of a registry prefix, a repository within that registry, and a tag. The tag can be a version number, a distro, or the special tag latest, which pretty much means what it says. So that's images. But if you actually want to do something, then you create a container. A container is like a tiny little machine booting up the image. You create a container using docker run. Specify the image that you want to start up. If you want to run the container interactively so that you can see what's going on and enter commands, then use the -it flags. These flags pair nicely with deleting the container once it's done, and so you do that with --rm. When it starts up, the container will run the entry point in the Docker file. But you can change the entry point with the --entry point flag. Typically you'll do this in order to run a shell, like bin bash. So that's pretty much what you'll need for the upcoming demos. Registries store images, Docker files build them, and containers run them. Now let's put this into action. Carlos wants to test the persistence layer for the application. The unit tests exercise domain services, but they don't give him confidence in the database persistence. So he'll start by creating a Docker image for integration tests. The container will run database migrations using a migration bundle. And then he will use Docker Compose to stand up a SQL Server container next to his integration test container. And finally, he'll run integration tests within the container to verify that the database persistence is working properly. To test database persistence, Carlos creates a Docker image. He starts with a Docker file that will build the code and run the unit tests. He runs a Docker build in order to create the image. To get a feel for how things work, he creates a new container and runs a shell. The next thing he'll want to do with this image is to build a migration bundle. So he tries out the command. The app is already built in the release configuration, and so he just uses that. It looks like he needs to install the .NET EF tools. And so he does a .NET tool install, and as the instructions say, he sets the path. And now he's able to run the command, but it looks like it needs the admin connection string. Now, the bundle tool isn't going to connect to the database right now, but we need the connection string in order to construct the DB context. And so he sets the connection string environment variable, even though the password here is incorrect, and then he's able to create the bundle. The tool has created an EF bundle executable inside of this directory. It also reminds us that the EF bundle executable is going to use app-settings.json in order to load configuration. We can get that app-settings.json from globoticket.api. Now when Carlos actually runs EF bundle, he's going to provide a new connection string, so it's not going to use the one that's inside of app-settings.json. Based on what Carlos has just learned, he adds a few steps to the Docker file. First, he'll install the EF tools at the very beginning so that those get cached. And then, after he builds and runs the unit tests, he'll create the migration bundle. Now he wants to run the migrations against a SQL Server instance. To create a SQL Server container running in parallel with the test container, he uses Docker Compose. This is where he'll set up randomly generated admin and application passwords. These are okay to check into source control because they're only used within the scope of integration tests. The services defined here, test and MS SQL, are visible to one another via TCP. The MS SQL service opens up a port on 1433 that test can connect to. Then he creates a script that will run all the tests. The first thing that it needs to do is to run migrations. This builds up the real administrator connection string using the admin password. Then he modifies the Docker file in order to run that script. He builds the image, which now creates the migration bundle, and then copies in the script to run the tests. And then he uses Docker Compose in order to bring up those services. It'll use the exit code from the test service, which means it'll wait for that container to finish its job. When the services start up, he can see SQL Server is starting, and then the test container runs the migrations. Looking good so far. And so he removes the services so that new volumes will be created every time. We don't want to keep old test databases around. The next thing that it needs to do after running migrations is to create the app user. The migrations created the database and set up the app role, so he has to wait for that to be finished before he can add the app user to that role. He rebuilds the Docker image, which now includes the integration test script. And then when he tries the Docker Compose up, he can see that the SQL command is not found. And so he installs the MS SQL tools right at the beginning of the Docker file. He puts this at the beginning so that those SQL tools get cached as well. Then he rebuilds the image again and does the Docker Compose up. And it looks like SQL command ran this time. It does not put any confirmation, but he knows that if he's able to connect as the app user and run the tests, then it will have worked. So let's do that next. The integration test project sits on top of infrastructure. It loads the app connection string from an environment variable, and then it calls add infrastructure in order to configure the container with that connection string. The container registers not only the DB context, but also the promotion service. And so the test resolves the promotion service from the container in order to run the tests. And so with that, all the script has to do is set that environment variable and then run the tests. He rebuilds the image in order to get that new script, and then he uses Docker Compose up in order to run the services. The database is created, the migrations are run, the app user is created, and the tests pass. And now Carlos has confidence that he can run the integration tests anywhere, at any time, even in the continuous integration pipeline.